Now we're going to learn something very interesting in statistics when you try to describe a data set, and that is called a box plot. There's a box here, so the graph basically look like this: a box and two sides. So generally speaking, the box plot will look like this. Let me explain how do we do that, and then we're going to discuss some various situations and how do you construct this box plot. All right, now if you can review, and what we have learned earlier is the measures of relative standing. And there we learned what is Q1 and Q2 and Q3. So we can create something called a 5-number summary. Okay, what is a 5-number summary? That means you should have 5 numbers. So they are minimum, Q1, Q2, Q3, and the maximum. Okay, so that's what you need to know. And the minimum is very easy to know, right? You just sort the data out, and then you can get the smallest the smallest value. And this one is the greatest value, so that's the maximum. And in the middle, this is called a 50th percentile or median, whatever you want to call that. Q2, 50th percentile, median, they're the same thing. And this Q3 is the third quartile or 75th percentile, and this Q1 is P25, so which is 25th percentile. So what it means is by getting these 5 numbers, then that means there are 25% of the number between minimum and Q1, that's 25%. And here from Q1 to Q2 it's 25%. It's just roughly, right? It might vary a little bit, but it shows the idea. And from Q2 to Q3, it's also 25%. And from Q3 to maximum, that's also 25%. That's pretty much tells you what the how the data was distributed, and then you find them. All right, now I will give you some example, and then you're going to know how to construct this. We can just review quickly what we did earlier, that 11, so when n is 11 waiting time. Do you remember the waiting time question at a Space Mountain, right, in Disney World? And then we have like the minimum was like a 20, okay, 25. I sorted, okay, so make it easier for you. 25, 25, 30, and then 35, 45, I believe there are 50, 50, 50, and the maximum is 75. So n is 11. Now what is the minimum? This guy, right? So that's your minimum. And this is your maximum. All right, now quickly review. How do you get a median? When you have 11 numbers, there are 2 ways to do it. The easiest way is to just use your fingers. 2 fingers, go from both sides to the middle, and then you find the number in the middle. That's your median. Or you do n plus 1 over 2 when n is an odd number. All right, so that will be 11 plus 1 over 2, which is a 6. Means your 6th number is your median. So that will be 1, 2, 3, 4, 5, 6. So there we go. Okay, so median or P50 or Q2, they are the same thing, and the value is 35. Okay, so the median is 35. Okay, now quickly, do you remember how to get a P25? 25th percentile, we get the locator, which is 25, times n is 11, divided by 100, so we get a 2.75, and then we always round up to the third, which means the third number, 1, 2, 3, the third number, this guy is my Q1. Okay, so Q1 is 25. Very similar to get the locator of a 75th percentile or Q3. So that is this. The answer is 8.25. We always round up. Keep okay, you got to remember this. So that goes to the ninth. So the ninth number, 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, I have Q3 equals 50. All right, now I'm going to use red color to mark it. So we have a minimum, we got a Q1, and then we got a Q2, and here, that's this guy. So that's our Q3, right? Q3. And then we have the maximum. We have the 5-number summary. Now 5-number summary looks like this. 5-number summary is 20, 25, 35, 50, and 75. This is called a 5-number summary. Minimum, Q1, Q2, Q3, maximum. And there are 25% of the data between 20 and 25, 25% of the data between 25 and 35, 25% of the data between 35 and 50, and again, 25% of the data between 50 and 75. So that's called a 5-number summary. All right, now this is the kind of like a quickly review about how to get those minimum, Q1, Q2, Q3, and the maximum. And then we just need to put them in this order. That's your 5-number summary. All right, now next one is the most important. I leave it here. Okay, so I'm going to continue. So you're going to learn another concept. It's called IQR. That's interquartile range, which is Q3 minus Q1. That's the difference between these two. Okay, so in our example, that would be 50 minus 25. The answer is 25. So interquartile range is 25, which means from 25 to 50. In this interval with a length of 25, there are 50% of the data. All right. All right, are you ready for the next one? For the next concept, it's called boundaries, which the first one, the lower boundary will be Q1 minus 1.5 times IQR, and the upper boundary will be Q3 plus 1.5 IQR. What does that mean? Let's figure this out. Let's do the calculation first, and then I will explain this to you. All right, so we have a Q1, which is 25, minus 1.5 times IQR. We just found it earlier. So is that? Therefore, the answer will be 1.5 times 25, which is 37.5. So 25 minus that, my answer is negative 12.5. All right, now Q3. Q3 is 50. So 50 plus 1.5 times 25. And that is 87.5. Super, super important. We are going to use these two boundaries to determine is there any is there a or any, it doesn't matter because we don't know how many outlier. Is there an outlier? Okay, as long as you have the number outside, means below this lower boundary and above the upper boundary, higher boundary, that is an outlier. Now, if you go back to here, do we have any number less than negative 12.5? No. Do you have any number greater than 87.5, greater than the upper boundary? No. Therefore, in our case, we have no outlier. So that's very simple answer for the. It's very simple answer for this one in order to find the outlier. All right, now next step is to construct the box plot. And I have the box plot. I know the 5-number summary, and I know there's no outlier. So I'm ready to construct a box plot. When you construct the box plot, I always draw the number line. Always draw the number line. And then you're going to look at here, the minimum is 20, and the maximum is 75. So what I would do, I would put 20, okay, and then I would do like, 20, and then 30, okay, 40, looks like a number line, right? You don't really need to start from 0. It just, as long as you show the idea, you're good. All right, okay. And then for the middle 3 numbers, you're going to put a bar on top of the corresponding value, which means there's a 25, 35, and a 50. So 25, right? That's right in the middle between 20 and 30. And the next 35 is right in the middle of a 30 and a 40. And the last one is a 50, so it's right here. I draw 3 lines and then I connect them. Do I get a box? I get 2 boxes. 25% of the data here, 25% of the data here. And as a good habit, I always put the number on top, okay, of the bar to make it easier later to check whether you draw the bar at the correct point. All right, now since there's no outlier, now we go to find where's the minimum value. Here is the minimum value. So from the minimum value, I draw the whisker. Okay. And then the highest value is 75, so I'm going to draw it like that. So I put a 75 and I put a 20 here. That's a beautiful box plot. Isn't it easy? All right, now what it says is 25% of the data here, 25% of the data here, and then for the upper side of the number above the median, the data get spread out. So that's why the box is much wider here. So 25% of the data between 35 and 50, another 25 between 50 and 75. So that's what this box plot tells you. Okay, one more thing I want to mention is if you have the histogram, looks like this. Okay, do you remember this is called a skewed to the left because it looks like the toe, like the toe shape of your left foot. So if this thing happened, where is the middle? Middle is somewhere around here. So the middle box here, and the data on the right side are pretty much concentrated. So most likely going to get something look like this. And on this side, on the left side, because the data spread it out, so you're going to have, looks like that's your box plot. So, all right. And for bell-shaped distribution, when you have the bar looks like symmetric and a bell-shaped, and the box plot look like this, because there are more data concentrated in the middle. It's pretty much symmetric, so there's 2 boxes about the same size. And then, sorry, I didn't really match. It should be somewhere here. And then you have longer tail on both sides. So that if you see the box plot look like this, that's pretty much match with that bell-shaped. What about the uniform distribution? Uniformly distribution. Let's see. We look at the day that the students were born. If you check your date of birth and you find out whether it's Monday, Tuesday, Wednesday, or all the way to Sundays, you get 7 bars. They're pretty much equally likely to be everywhere. So you're going to have something look like this. All right. So about 25, about 25, about 25, and 25. So the width of the whisker is about the same as the width of each box. Okay, so that's a relationship between the histogram or distribution with the box plot. So box plot basically can tell you a lot of things. All right, now there's some special situations of the box plot. What happened? There's one outlier. For example, I'll give you one example. Okay, if you have a minimum is 20, given a 5-number summary, okay, and the Q1 is, just use this one, okay, our Q1 is 25, okay, and the Q2 equals 35, and 3 equals 50. Okay, now if you remember, we have the maximum value of 75 before. What about if I put the maximum value 115? That's a big number, isn't it? I change one single number here. It will not change minimum Q1, Q2, Q3. The only thing changed in this 5-number summary is 115. Since minimum Q1, Q2, Q3 not changing, so I will keep going. I will keep using this data I will keep using this. Interquartile range is still 50 minus 25, and the boundaries, the lower boundary is negative 12.5. Okay, I don't have any number below that. For the upper boundary, 87.5, I do have one number. 115 is greater than that. Therefore, 115 is greater than 87.5, and you still remember how to get that 85, right? Q3 plus 1.5 IQR. All right, now since this, then 115 is an outlier. Well, 115 is an outlier. And the data we have, let me just put it here. And the data we have right now, I only change this guy. I only change this guy to be 115. Now I'm going to construct the box plot, okay, for this new data set with 11 numbers. Again, I'm going to draw the number line, and then the minimum is 20. So I'm going to 20, 30, 40, 50, 60, 70, 80, 90, 100, and not that yet, 110, and 120. All right, now I'm going to do Q1, Q2, Q3. I'm going to draw the lines. 22, that's Q1. That's, 25. And then 35, that's my Q2. And then 50, that's my Q3. So I got the two boxes right in the middle. Okay, and for the lower side, my minimum value is 20. So yeah, I just do that. I just put a 20 here. So I have the little, a very short whisker on the left side. That's it. But on the right side is different. Okay, now look, because this 115 is my outlier, it's right here. What I'm going to do is I'm going to put a little star here, put a 115. So when I see the box plot with a star, I know it's an outlier. Okay, so far I have one outlier. After you finish indicating this outlier here as a star, then you go to the next value to see if this guy is an outlier. If this is one outlier, then you just draw another star, and then you go to the next lowest, next highest value. Okay, but in our case, this 115 is an outlier, and a 50 is not greater than 87.5. So 50 is not an outlier. So we're going to draw we're supposed to draw a point for 50 and connect that to here. But did you notice that this is a 50 and this bar is also 50? So this is a 50 and this bar is a 50. So this box plot don't have the right whisker. Don't have the whisker on the right side. So that's your box plot look like. Now you learned this is a very special situation. You have an outlier and you know how to identify outlier. You have to figure out the lower boundary, upper boundary to see whether you have any number outside these two boundaries. If you do, then you use a star to indicate that. Then after you indicate your outlier, then you go to the number which is not an outlier and treat that as your new maximum when you draw the box plot. Sometimes your new maximum or even just the maximum has the same value of your Q1 or Q3, then that means this line and this dot, they just stay together. So there's no whisker. You know, sometimes even that Q1, Q2, they collapse. So for this, a box is almost like nothing there. So sometimes that happened too, but it's very rarely that happen. So this give you some just idea about it when you see the special situation and then what you're going to deal with how to draw the box plot. Okay, so then we learned, we finished this part, so you know how to do box plot. Before that, you get to know how to figure out a Q1, Q2, Q3, calculate the IQR, and then find the upper boundary and the lower boundary, and then decide whether is there any outlier, who are they, and then you construct the box plot. So it's a good habit. You know, I always draw the number line and I put the bars, and I like to put the numbers on top just in case. You know, sometimes you might draw the bar in the wrong place you didn't know, and then you come back and you can check, you find out. All right, so that's all for this class.